In section 3, we're going to talk about horizontal and vertical translations of functions. Translations means movements. A translation is a move either up and down or side to side. The general shape stays constant, it just moves up or moves down, or moves to the left or moves to the right. In general, a translation is a type of transformation. A transformation is any change made in the figure or a relation, such that the figure of the graph is shifted or changed in shape. There are 3 types of transformation: translations, movements. Stretches are what you see if you were on Microsoft Word and you had a little picture of a happy face and you had little corners. And everybody knows about these little corners. If you go to the corner, click on your mouse and pull up, you get a really thin happy face. You get like long eyes and long thing. That's a stretch. Reflections are when we have, let's say we had our hand, 4 fingers on a hand, and a thumb. And if we did a reflection, it's what it would look like in the mirror. Okay? When it's flipped from one side to another, that's a reflection. A translation is a transformation that results in a shift of the original figure without changing its original shape. So how do we write this in function notation? Well, we say the graph g of x equals f of x plus c. So our new is the same as our old graph plus some constant. This is a vertical translation of the original graph by c units. If c is greater than 0, if it's positive, the graph moves up. If c is negative, the graph moves down. This is very similar to our idea of a vertex of a parabola. We normally have a vertex here, and this graph is f of x equals x squared. Well, we could have f of x equals x squared minus 2. That would mean the vertex moves down 2. And then we have our new graph. So this is a vertical translation. We can also have horizontal translations. Horizontal translations are not up and down like the vertical ones. These ones are side to side. We show that not with a constant term outside. The term is inside the function, and I'll show you how that looks when we're working with different equations. So the graph g of x is equal to f of x minus d. This is a horizontal translation of the graph f of x by d units. If d is greater than 0, that is to say if d is positive, then the graph moves to the right d units. And if d is negative, then the graph moves to the left d units. What you have to keep in mind here is that this is always a negative sign. And I'll show you how that plays out when we see it in some actual questions. A sketch of the graph of any transformed function can be created by transforming the related base function. So we'll talk about what different base functions look like. Base functions are functions you should be able to identify. We know a whole bunch of them. We know straight line functions. F of x equals x, and this straight line function would go right through the origin. We know the quadratic, f of x equals x squared. These are the 2 base functions that you're most familiar with. And in general, we can talk about domain and range of the new function, much like we can talk about the domain and range of the old function. Let's try some examples. Example 1. Given the graph of function f of x, so this graph here, random graph that I can't give you an equation for, is called f of x. We've got the graph of f of x. We want to sketch the graph of g of x. G of x is going to be the same as f of x, but it's going to be 4 higher up. Plus 4. This is an external constant to the function. This is a vertical translation. It's a vertical translation of 4 units. That means take every point, and helpfully I've labeled A, B, C, D. Every single point has to move 4 points up. 1, 2, 3, 4. There it is. For B, 1, 2, 3, 4. For C, 1, 2, 3, 4. And for D, 1, 2, 3, 4. I happen to have labeled A, B, C, D. They seemed like the natural points. If you want to take a look at any other point in between, 1, 2, 3, 4, it would also go up. We connect. And this is our new function, g of x. Vertical translation of 4 units. We want to take a look at the second example. This is our new base function. In this case, g of x, my mistake, f of x is equal to the square root of x. If you were to do it on a table of values, the points that you would plot would be 0 and 0. And when x equals 1, what's the square root of 1? 1. It's hard to do the square root of 2, it's hard to do the square root of 3, but it's not so hard to do the square root of 4. That's 2. So the points that we're going to plot are 0, 0, 1, 1, 4, 2. And if you want, 5's no good, 6 gives me a decimal, 7 gives me a decimal, 8 gives me a decimal, but 9, square root is 3. This is a base function called the square root function. If we take a look at our g of x has a translation, because it's a plus. It's a translation of 4 units. But if you take a look, the general form for a horizontal translation, like this one is, has not a positive sign there. It's got a negative sign. So if we've got a positive sign here, this would be the same as minus negative 4. So this is telling us that we need to move left 4 units. Not right 4 units, left 4 units, backwards if you will. So each of these points has to move 1, 2, 3, 4 units to the left. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So our graph looks like this. Now it hasn't been asked for, but we can do domain and range. Let's see, of g of x of our new formula, what is the domain? Well, the domain, we've got an arrow on this end. This line continues on and on and on, but it's got a definite starting point. There are no values in the domain before x equals negative 4. So x has to be greater than or equal to negative 4. For range, that's our y values. It keeps going up and up and up. It doesn't go very quickly, but it will keep increasing. But it does have a lower limit. Our range is y. It has to be greater than or equal to 0. For this one, for our g of x domain, well, we've got a definite starting point and a definite ending point. Our starting point is most certainly negative 3, and it goes all the way to positive 4. So x has to be somewhere in between negative 3 and positive 4. I've forgotten something. X has to be a member of reals. And the other one, I knew I was forgetting something. X is a member of reals, and x is a member, y is a member of reals. For our range, y is a member of real. What's the absolute lowest value the y can be for this pink line? Well, it starts at 2, right there. What's the highest value it could be? 5. So y has to be between 2 and 5. So in the second example, we're going to look for each function g of x, here, here, and here. We're going to describe the transformations from a base function. The base functions that may be used are f of x equals x, f of x equals x squared. So that's the parabola, straight line, parabola. We've got f of x equals square root of x. So this guy is f of x equals x squared. We've got f of x equals x, f of x equals x is a straight line. F of x equals x squared is a parabola. So what are the points that we would use for the parabola? Well, we do x equals 0, y equals 0, x equals 1, y equals 1, x equals negative 1, y equals negative 1. We continue on like that. We'd have f of x equals square root of x. That's the one we did in the previous example, the square root function. And a final new guy, f of x equals 1 over x. Rational function. Let's plot some points and see what happens. Well, let's do negative 2, negative 1, 0, 1, and 2. If x equals negative 2, what does this equal? Sorry, there you go. Well, negative 2 in there, negative 0.5. If I put in negative 1 into this equation, 1 divided by negative 1, negative 1. What about if I divide by 0 here? Can't do it, undefined. 1 and 0.5. This is something very strange looking. In this one, at x equal to 0, we have what's called an asymptote. An asymptote is a line a graph approaches but never really reaches. On this side, as x gets bigger, the y gets smaller. On this one, as x gets more and more negative, y approaches 0 from the bottom. This is f of x equals 1 over x. So these are our 4 base functions. 1, 2, 3, and 4. Let's take a look. If we're looking at g of x, I see that I have a squared. I have something x squared. That tells me it's not this purple one. Could be the green one, not the pink one, not the orange one. We must be talking about the base function f of x equals x squared. So if that's our base function, what transformations have happened to this? Well, we've had, we're going to go up 1 based on this. And this is telling me we're going to move 5 either left or right. Think of it as negative, negative 5. Our horizontal transformations are always negative x. We want to move to the left 5. So what I typically do with these kind of questions are very lightly first graph my base function, my f of x. 0, 0, 1, 1 for my parabola. Next point of the parabola is 2, 2 squared is 4. There we go. If I want, I can go to 3, 9. The other way to graph the parabola is the step pattern. 1 up. From here you go 3 up. From here you go 5 up. Next one you'd go 7 up. If this is f of x, well, what's g of x? For g of x, we're going to take each point move it up 1 and over 5. 1, 1, 2, 3, 4, 5. Okay. From here we're going to move up 1, 1, 2, 3, 4, 5. From here we're going to move up 1, 1, 2, 3, 4, 5. And I'm losing my dots. Paper got all faded. Up 1, 1, 2, 3, 4, 5. Symmetrical on the other side. 1. There we go. Trying to line it up nice. Oopsies, but I've gone too far over. 5, 1, 2, 3. Yep, there we go. This is my g of x. For each function g of x, describe the transformation from the base function of this, first by using function notation, and then using words. The transformation of f of x. Transform the graph of f of x to sketch the graph of g of x, and then state the domain and range of each function. So, if we want to use function notation, we would write g of x equals f. We'd write x minus -5 plus 1. In words, g of x is the same as f of x when you move f of x 1 unit up and 5 left. So I've described it at function notation, I've described it using words, I've sketched, and now it's time for domain and range. So let's first do domain and range of f of x. F of x, our original parabola. What's the domain? What are the possible x values? Will they go on forever? Domain. X is a member of real. For our range, well, all the y values have to be greater than 0. Y is a member of real, y has to be greater than or equal to 0. For our g of x, our new transformed function, well, let's go see. Yep, domain is still all real numbers. Our range here's the low point. This is our minimum of our parabola. All the y values have to be greater than or equal to +1. Y is a member of real. Y has to be greater than or equal to 1.